You carry a very simple picture of temperature. If something is hot, it must be moving. If something is cold, it must be still. And if something is not there at all, then it must be perfectly cold. This picture feels natural. It feels unavoidable. It feels like common sense. You touch a hot surface, and you feel agitation. You touch a cold surface, and you feel stillness. You step into a cold room, and the air seems quiet, heavy, unmoving. So your brain quietly builds a rule. Less motion means less heat. No motion means no heat. From there, the conclusion feels inevitable. Empty space with nothing inside it must be the coldest thing that exists. But this reasoning is built entirely on humans' scale experience. Everything you have ever touched, seen, or felt is made of matter. Everything around you operates at temperatures billions of times higher than the deepest cold in the universe. Your intuition has never encountered true emptiness. It has never encountered near-zero energy states. It has never encountered physics operating at its limits, so your brain extrapolates. It assumes the pattern continues. Remove air, right arrow, it gets colder. Remove more particles, right arrow, colder still. Remove everything, right arrow, absolute zero. This feels logical, but physics does not care how logic feels, because temperature is not really about warmth. It is not about comfort. It is not even about motion in the simple way you imagine. Temperature is a measure of how much energy is trapped inside a system. And here is where your intuition quietly fails. You assume energy belongs to matter. You assume that without particles, there can be no energy. This assumption is so deeply embedded that you rarely question it. Energy feels like something that things have, not something that space itself could possess. Yet physics does not describe space as a passive container. It describes it as an active participant. This is where the discomfort begins. Because the moment you stop treating space as a backdrop and start treating it as a physical system, the entire idea of cold emptiness collapses. In your daily life, emptiness means absence, no air, no sound, no movement. But in physics, emptiness means something far stranger. It means the lowest energy state that reality is allowed to occupy. And that lowest energy state is not zero, not even close. You imagine absolute zero as the natural resting point of the universe, as the calm ground floor beneath all motion. But nature does not permit that floor to exist. The universe does not allow complete stillness, not for atoms, not for particles, and not for space itself. Your intuition insists that stillness is simple. Physics insists it is forbidden. And the deeper you go, the clearer this becomes, because emptiness is not absence. It is tension. It is structure. It is restless, and it always carries energy even when nothing else is there to carry it. This is wrong according to everything your senses have taught you. And yet, it is exactly what experiments keep confirming. The coldest places we can create still glow faintly. The quietest vacuums still flicker with activity. The emptiest regions of the universe still radiate heat. Not because something is hidden there, but because nothing itself refuses to be still. You imagine vacuum as a hollow, a region scraped clean of everything. No air, no dust, no light, no particles, just empty extension. This picture feels simple. It feels precise. It feels scientific. But it is wrong, because physics does not define vacuum as nothing. It defines vacuum as the lowest energy state the universe can physically allow. That difference is subtle, and it changes everything. When engineers create a vacuum chamber, they remove air. Then they remove water vapor. Then they strip away stray molecules. They cool the walls. They pump relentlessly. And eventually they reach what they call high vacuum. But what remains is not emptiness. What remains is a seething, fluctuating field of activity too subtle for human senses, yet unavoidable for nature. Particles appear, they vanish, energy pulses, fields oscillate, not because something is leaking in, but because the structure of reality itself will not stay quiet. In classical physics, emptiness was simple. If there were no particles, there was nothing left to describe. Quantum physics destroyed that picture. In quantum theory, particles are not fundamental. Fields are. Every type of particle corresponds to a field spread throughout all of space. Electrons have a field. Photons have a field. Even more exotic entities have their own fields. And these fields never shut off. Even when no particles are present, the fields remain. And when fields remain, fluctuations remain. You cannot freeze a field. You cannot silence it completely. You cannot lock it into perfect stillness. If you tried, you would violate one of the deepest rules of quantum mechanics, uncertainty. At the smallest scales, reality cannot have both perfectly defined energy and perfectly defined time. If a system exists for any finite duration, its energy cannot be exactly zero. So space, which exists continuously, cannot settle into total energetic silence. This is not a technical limitation. It is not a flaw in our machines. It is a built-in property of reality. Even in absolute vacuum, fields jitter. They fluctuate. They borrow energy from nothing, then repay it. Particles briefly form, then annihilate, not as rare accidents, but as constant behavior. This means the vacuum is not empty. It is a restless baseline, and wherever there is restless energy, there is temperature. Not temperature in the familiar sense of heat you feel on your skin, but temperature as physics defines it, a measure of unavoidable energy presence. This is the uncomfortable truth. If you removed every particle from a region of space, you would not create nothing. You would reveal the low-energy dynamical system that reality permits, and that system is still alive with motion, still alive with fluctuation, still alive with heat. This redefines what emptiness even means. It means that nothing is not a void. It is a carefully balanced tension, a quantum hum beneath existence, and once you accept this, a new problem appears. If vacuum itself contains energy, if it cannot be perfectly still, then absolute zero is not just hard to reach. It becomes fundamentally unreachable. You think of absolute zero as a destination, a point you could reach if you just cooled something enough. A finish line at the bottom of the thermal scale. 0 Kelvin, no motion, no energy, perfect stillness. This idea feels mathematically clean. It feels physically reasonable, but nature treats it very differently. In physics, absolute zero is not a temperature. It is a boundary, and boundaries behave strangely. As a system cools, its ability to release energy slows down. The colder it becomes, the harder it is to remove what little energy remains. Each step closer to zero requires disproportionately more effort, not because our technology is crude, but because the structure of thermodynamics itself resists the approach. The laws of physics quietly forbid reaching absolute zero in a finite number of steps. No process, no matter how clever, can remove all energy from a system. There is always some remainder, some jitter, some irreducible agitation. But the deeper reason is not engineering. It is quantum mechanics. At microscopic scales, particles cannot be completely still. If you tried to force perfect stillness, you would also have to define their exact position. And that combination is forbidden. Perfect rest would require perfect knowledge of both momentum and location. Quantum mechanics refuses to allow this, so even at the lowest temperatures, atoms still vibrate, electrons still blur, fields still fluctuate, and as long as motion exists, temperature exists. This reveals something subtle and unsettling. Temperature is not merely a property of matter, it is a property of existence itself. Even if you could somehow erase every particle, the vacuum fields would still carry energy. Even if you stripped away radiation, quantum fluctuations would still generate activity. So absolute zero becomes not a real state, but an abstract limit. A mathematical fiction the universe approaches but never reaches. And this limit is not special only in laboratories. It is written into the fabric of space-time, because the universe itself has a temperature. A faint one, a nearly invisible one, but a real one. No matter where you go between galaxies, beyond stars, deep into cosmic voids, you are immersed in a background warmth. Not from stars, not from matter, from the echo of the universe's own birth. This temperature does not depend on your location. It does not depend on nearby objects. It exists everywhere, which means space itself is warm. Not in the way your skin understands, but in the way physics cannot ignore. And once you realize the universe has a baseline temperature, you are forced to confront a deeper truth. Space is not passively cold. It is actively heated from all directions, at all times, by the very structure of cosmic history. You assume darkness means cold. When you picture the deepest parts of space, you imagine frozen silence. No stars, no light, no warmth. But even the darkest regions of the universe glow, not visibly, not dramatically. They glow thermally. Every direction you look, space itself radiates a faint, uniform heat, not from stars, not from galaxies, not from dust, from the universe. This is not a metaphor. It is a measured fact. No matter where we point our instruments, we detect the same background temperature, a temperature that does not fade with distance, a temperature that does not belong to any object. It belongs to space itself. This background warmth is the afterimage of the Big Bang. A fossil heat stretched thin as the universe expanded. In the early universe, everything was compressed into extreme density. Energy and matter were inseparable. Temperature was unimaginably high. As the universe expanded, that heat diluted. It cooled, it softened, but it never disappeared. Instead, it became a whisper that fills all of space. Even now, billions of years later, that ancient heat still lingers, not trapped inside stars, not bound to galaxies, but embedded into the vacuum. This means the coldest natural temperature in the universe is not zero. It is this faint cosmic background. Space itself sits inside a thermal bath created by the universe's origin. And you cannot escape it, no matter how far you travel, no matter how empty the region appears, no matter how isolated you become. You are always inside this background glow. This quietly shatters another intuition. You imagine heat as something that spreads outward from hot objects. You imagine warmth as something localized. But here, warmth is everywhere first. Stars do not heat space. Space already has heat. Stars merely rise above that baseline. This means emptiness does not cool things to zero. It cools them only to the temperature of the universe itself. Even in the absence of matter, radiation, and structure, space retains memory. Memory of compression, memory of origin, memory of creation, and that memory expresses itself as temperature. But this is still not the deepest layer, because even if the universe had never expanded, even if it had never cooled, even if no cosmic background existed at all, space would still not reach perfect stillness, because beneath cosmic heat lies a more unsettling source of motion, one that does not depend on history, one that does not depend on stars, one that does not depend on expansion. It comes from the deepest rules of reality itself. You imagine that if everything were removed, stillness would finally win. No particles, no radiation, no motion, at last silence. But at the deepest level of reality, silence is not stable. Quantum mechanics does not allow perfect calm. Not anywhere, not ever. Even in absolute vacuum, space is alive with microscopic agitation. Not because something is moving through it, but because uncertainty is built into existence itself. At quantum scales, energy and time are locked into a trade-off. The more precisely you define one, the more uncertain the other becomes. This means that for any region of space that exists for any measurable duration, its energy cannot be exactly zero, not even for an instant. So the vacuum fluctuates. Energy briefly appears, then disappears. Particles form, then annihilate, not as rare events but as continuous background behavior. This is not theoretical speculation. It is directly measurable. These fluctuations produce observable forces. They shift atomic energy levels. They generate pressure between metal plates. They leave fingerprints everywhere, which means empty space is not inert. It is restless. You might try to imagine this as tiny particles popping in and out of existence. But that picture is still too simple. What fluctuates is not matter. It is the underlying fields of reality. The same fields that generate all particles never stop trembling. They cannot be frozen. They cannot be silenced. They cannot be switched off. This means the vacuum is a storm of microscopic activity, not violent, not dramatic, but unavoidable. And wherever there is unavoidable activity, there is energy. Wherever there is energy, there is temperature. This is where the idea of cold emptiness finally collapses. Because even if you removed every trace of cosmic background heat, even if you isolated a region from all radiation, even if no particles were present at all, quantum mechanics would still inject motion, still inject fluctuation, still inject warmth. Not warmth you could feel, not warmth that would melt ice, but warmth that prevents absolute stillness from ever existing. At this level, temperature stops being a property of objects. It becomes a property of reality itself, a baseline trembling that cannot be eliminated, and this trembling is not accidental, it is structural. If the universe were ever allowed to reach complete stillness, its laws would break. Time would lose meaning, energy would lose definition, existence itself would collapse into paradox. So the universe enforces restlessness, it forces motion, it forces fluctuation, it forces heat, even where nothing seems to be. This means space is not just warm because of cosmic history. It is warm because reality cannot tolerate perfect quiet. And this leads to a deeper, stranger realization. Temperature does not merely live inside matter. It emerges from space-time itself. You think temperature is about particles, about atoms colliding, about molecules vibrating, about matter in motion. This belief feels so fundamental that questioning it seems absurd. But physics quietly breaks this connection, because temperature can exist even when particles do not. And the key to this lies not in matter, but in motion through space-time itself. Imagine floating motionless in deep space, no stars, no radiation, no particles, just silence. Now imagine accelerating. Not toward anything, not away from anything, just accelerating, nothing else changes. Yet, according to quantum physics, you would suddenly detect heat. Not because something warmed you, but because your motion through space-time created temperature. This is not metaphorical. It is a direct physical prediction. An observer at rest sees empty space. An accelerating observer sees a thermal bath. Same location, same vacuum, different motion, different temperature. This destroys a powerful intuition. Temperature is not absolute. It depends on how you move through space-time. At this level, heat stops being about particles and becomes about perspective. Even more unsettling, gravity produces the same effect. Near a black hole, empty space heats up, not because matter is present, but because space-time itself curves so intensely that it generates thermal behavior. Black holes glow, not from fire, not from matter, but from geometry. Their gravity bends space-time so severely that the vacuum itself radiates heat. This means temperature can emerge purely from the structure of space-time. No particles required, no matter necessary, just geometry and motion. This is where your classical understanding finally collapses, because now temperature is no longer a property of objects. It becomes a property of how reality is arranged. Acceleration creates temperature. Gravity creates temperature. Horizons create temperature, and space itself becomes a thermodynamic system. At this point, emptiness has completely lost its meaning. Space is no longer a passive backdrop. It is an active participant. Its shape, its motion, its curvature all generate heat, even when nothing else exists. This suggests something deeply unsettling. Temperature is not a side effect of matter. It is a fundamental feature of space-time, and once you see that, a final realization becomes unavoidable. The universe is not warm despite emptiness. It is warm because emptiness is impossible. You imagine a universe that could ever be completely empty. No energy, no motion, no vibration, no heat, a perfect void. This idea feels logical. It feels like the ultimate end of cooling. It feels like a simple thought experiment, but physics tells a harsher story. Absolute stillness is forbidden. Perfect emptiness is unstable. Zero temperature is a limit, not a state. Even if all matter were removed, even if all cosmic background radiation were eliminated, even if all motion were somehow erased, quantum mechanics would insist on fluctuation. Relativity would insist on heat from acceleration or horizons. Space-time itself would refuse silence. Reality enforces restlessness. This is not a flaw. It is not an oversight. It is a rule baked into existence itself. Even nothing is something. Even emptiness hums. Even vacuums glow. Even the void possesses a baseline of energy. And this has consequences far beyond physics. It suggests that the universe is self-sustaining, that space itself contains the seeds of activity, that silence, perfect stillness, and zero energy are illusions. Even the darkest void is alive with possibility. Every point in space vibrates with structure. Every corner of emptiness carries energy. The philosophical implication is unsettling. The universe cannot rest, it cannot pause, it cannot forget its own existence. Even in what you thought of as nothing, the cosmos is awake. Space has a temperature because the universe refuses to tolerate true nothingness, because existence itself is a restless, dynamic state, because emptiness is forbidden, and once you understand this, the way you picture reality changes forever. Cold emptiness is a myth. Vacuum is alive. The universe itself hums, and in that hum lies the strange, unavoidable truth. Temperature is not a property of things. It is a property of reality, of space, of time, of being itself. No matter how far you strip away matter, no matter how much you isolate, no matter how deep you peer into the void, you will find warmth, the faintest, most persistent glow of existence. And that warmth is not optional, it is unavoidable, it is fundamental. The universe does not permit nothing. It does not permit perfect stillness. It does not permit absolute zero. It permits only this, a restless, trembling, eternally warm reality, and that is why space has a temperature at all. It is not a mystery, it is a rule, a hum of being written into the fabric of existence itself. The void is alive, and it always has been. This is the mind-boggling truth physicists found.